Hello there, welcome to this video today where we're going to be looking at Boolean logic, so let's get cracking. So first we're going to be doing today is your spelling test, so make sure we're ready for this. Make sure you've also written your name and your class at the top of your booklet and tick the learning outcome that you're going to go for, and let's get going. So word number one is algorithm. If I'm going to write something as an order of instructions, I am going to be making an algorithm. Algorithm. Number two, you can sort information into the correct order. Sort. Number three, you can also search for data. Search. Number four, a type of sort is a bubble sort. Bubble. Number five, a piece of information that can change is called a variable. Six, an example of data is a variable. Data. Number seven, binary is a language used by the computer. Binary. When the computer receives an input, it has to process it. Process. A computer decides things using logical statements. Logical. And number 10, you want an algorithm to be as efficient as possible. Efficient. So make sure you got all 10 answered. If you haven't, just rewind the video quickly and get them all filled in. And then we'll get the answers up, and then you can self-mark the work that you've done. So there are the answers you've got, 1 through 10 there. Give yourself a tick if you got the answers correct. If not, put a little cross and rewrite the answer out that you can see on the screen now, and then we can get cracking. So, computers process data all the time. If we're thinking about how they work, how they operate, they do things all the time. It processes information input coming in. So at the moment, my computer is processing the data coming in from my microphone. And essentially, when it boils down to things, it works through things called logic gates. So all the information, as we looked at previously in lesson, things being broken up into ones and zeros, into binary numbers, that's what the computer uses, ones and zeros, to process different pieces of information. How does it do this? It uses these things here, which are called logic gates. And so what we're going to be thinking about is what logic gates are, how do they operate? And that will lead us on to the first task on page 1 of the booklet. So this is an AND gate here. We can see the AND gate has 2 inputs coming in and 1 output coming out. And then what happens in this AND gate is, based on the 2 inputs coming in, the output is given. So we can see if A and B are both 0, the output is going to be 0. If A is 0 and B is 1, the output is going to be 0. If A is 1 and B is 0, the output is 0. The only way the output of an AND gate is 1 is if both A and B are both 1. We've also got an OR gate. Again, 2 inputs coming in, 1 output. The difference between the OR gate and the AND gate is it's a lot easier, or more options to get an output of 1. If we're having A or B as 1, or both of them as 1, we'll always get an output of 1. If both A and B are both 0, we'll get the output of a 0. So with an AND gate, we've only got 1 possible output as a 1. With an OR gate, we've got 3. The other gate you need to be aware of is called a NOT gate. And here we've only got 1 input coming in and 1 output coming out. And what that does is it just flips it around. So if we've got a 0 coming in for A, we've got a 1 coming out. Similarly, if we've got a 1 coming in for A, we've got 0 going out. So what I want you to do now, nice, easy and simply, is on the page 1, I want you to line up and match up the different logic gates you've got on the left hand side with which one they are and or are not on the right hand side. Give the video a quick pause, get that done, and then we'll move on. So what we can do is we can create logic circuits, and what logic circuits are a series of gates put together. So here we've got two inputs here, A and B. So we can see A goes to the NOT gate, which then goes to the AND gate, which then goes to the OR gate. And A is also used in this OR gate here, the value of which goes to this AND gate, and it also goes to the OR gate here. So if we're saying that A is worth 1, it goes onto here to this NOT gate, it's going to be worth 0. So straight away we've got a 0 coming in on that AND gate. Similarly, we've got a 1 coming here, and if we're going to say B is 0, we've got 1 or 0. That gives us 1, which is then going to go this way to the OR gate, and also going up this way to the AND gate here. So here we've got 0 and 1, which of course will give us 0 coming through. But then we've got the 1 from the B coming along here, so 1 or 0 will give us 1, so we know that Z equals 1. If we think that A and B are both 0, so A is worth 0, it hits the NOT gate, gets turned into a 1. So then we've got a 1 here for this input here on the AND gate. We've also got a 1 coming in, a 0 coming in onto this OR gate here, and we've got a 0 or 0, of course gives us 0, so we've got a 0 going over to here, 0 going to here. 1 and 0 of course gives us 0, so then 0 or 0, Z in that case is equal to 0. So what we can do, we can use these quite nice and happily to create logic circuits. So logic circuits can be used in any area. So for example, before I started teaching, I was involved with a company that was programming the landing gear on Boeing airplanes, and we had to series thousands and thousands of logic circuits to make sure the landing gears went right at the right time, at the right angle, because obviously you don't want your landing gears coming down in mid-flight. So if you open up your booklet now, we can see the two inside pages. Top left part's nice, easy and simple. You've got 3 tables there. I want you to work out, firstly, which table is used for AND, for OR and for NOT. Fill in the missing values. We've then got 3 different logic circuits for you to complete. The logic circuit on page 2, the value of A is 1, the value of B is 1, the value of C is 0. So A and B are both 1, C is 0. And I want you to work out what X is, the end value. On logic gate number 2, which is on the top part of page 3, the value of A and B are both 0, the value of C and D is both 1, and again I want you to work out that end value at the end there. And then on the last value question on the bottom of page 3, we've got A, B and C, and they are all going to be worth 1 apart from B, which is worth 0. So A and C are 1, B is 0. So pause the video, feel free to look back in the earlier videos to look through different logic gates and work out what the value of Q will be on that one. Again, with each one, what I would personally do is if I had this in my booklet, if A is worth 1, I'd start off by writing a 1 here, and then the other side of the NOT gate, I'd write a 0, so then I can see the values working through that. Once you've done that, pause the video, and then we'll get on to the final question at the end. So, last 2 things we're going to look at. If you go to your back page, you will see that there is an empty box there. What I want you to do is I want you to give me a challenge. I want you to construct a logic circuit there, give me the initial values of what the inputs are, and then I will work out for you what the output will be. Once you've drawn that logic circuit, I want you to be answering today's key questions. What are logic diagrams and what are logic circuits? So if we're thinking we can see a logic circuit to begin with. Logic diagrams are the AND, OR and NOT gates we looked at the beginning. I want you to put that down in words. Okay? Fantastic. Again, with that one, if you go over the page, as I've said in the previous lessons, that's completely fine. Get the work done, and I shall see you in another lesson. See you later.